14, in the diagram below, EF is the median of trapezoid ABCD. If AB equals 5x plus 9, DC equals x plus 3, and EF equals 2x plus 2, find the value. What is the value of x? Okay, so our median, our EF, is 2x plus 2. Then we have AB is 5x minus 9 plus, right, DC x plus 3 all over 2. This is the formula for median. So all I did was plug in the numbers into the formula. Okay, then we combine like terms. 5x plus x is 6x. Negative 9 plus 3 is negative 6. Okay, and this still stays over 2. Now, just going to, right, and I'm actually going to split this up so you can see it a little better. Okay, and then do the division, right? So I could get rid of this fraction, and this will become 3x, and this will become 3. Okay, so then I will solve it, right? So I'm going to draw on here. I'm going to take away 2x because I like moving the smaller coefficient so that I can not have to work with negatives. And we get x. Then we add 3 to both sides. I'm just going to leave that here so you see what I did. Okay, add 3 to both sides, and I get 5 equals x. Okay, let's take a look at the next problem. I'm just going to put this up here so you can see it better. X equals 5. Okay, our next problem is in the diagram, right? This is number 14. In the diagram, trapezoid ABCD below, AB is parallel to DC. Okay, AD is congruent to BC. Angle A is 4x plus 20. Angle C is 3x minus 15. What is angle D? Well, we know from the two sides being congruent that this is an isosceles trapezoid. Therefore, angle D is the same as angle C, right? And we also know that consecutive angles or adjacent angles, angles that are next to each other, right, add up to 180. So we put an equation together. 4x plus 20 plus 3x minus 15 equals 180. We got 7x, right, plus 5 equals 180. So then we're going to subtract 5 from both sides, right, and we get 7x. 7x equals 175. Okay, and x should equal 25. Okay, x equals 25. Okay, but we're looking for the whole angle, so we need to plug it in. So 3 times 25 is 75. 75 minus 15 is 60. Okay, D is 60, and you could also check here to see if this equals 120, right? 4 times 25 is 100, plus 20 is 120, 120 plus 60 is 180. Okay, now we have a proof, which I'm going to actually cover. I did all the answers already because I actually filmed this and I'm refilming it. Okay, we're going to go over it so you'll see the answers. All right. All right, so we have JKLM is a parallelogram. JM is congruent to LN. Angle LMN is congruent to angle LNM. Okay, that's what's given to us, and we need to prove JKLM is a rhombus. Okay, so we have that this is a parallelogram. Okay, and we know that JM is congruent to LN. We also know that LMN is congruent to LNM. Okay, so that's what's given to us. All right, from there we can show, from there we can show that JK, okay, and LM are congruent, right? And that's because opposite sides of a parallelogram are congruent. Okay, it's going to keep happening, I see. So then we have triangle LNM is isosceles, right? And that is because, right, if the two base angles are congruent, right, then the triangle is an isosceles triangle. Then we have, right, that LM is congruent to LN. Well, if this is an isosceles triangle, then two of the legs, right, opposite legs of the isosceles triangle are congruent. Okay, then, we have JM is congruent to LM, right? And this, of course, is from transitive property. Okay, so what that means is if JM is congruent to LN and LM is congruent to LN, well, then JM is congruent to LM. Okay? So I just want to read that again. So JM is congruent to LN and LM is congruent to LN, then JM is congruent to LM. That is transitive property. Okay, and then we have JKLM is a rhombus. A rhombus is a parallelogram in which all four sides are congruent. Okay, this was probably the hardest proof there on the review. Okay, moving on to question 16. Okay, and we have our statement and reasons. Okay. And over here we're given angle BAC is congruent to angle DAC. BAC is congruent to angle, right, DAC. And we're given angle B is congruent to angle D. Okay, and we know that CA is congruent to itself because of reflexive property. We need to prove that BC is congruent to DC. Okay, this one's not bad at all. I'm going to split this. Okay. So we have all this beautiful stuff. Just going to crop it because I don't feel like rewriting it all. Okay. And this is all given. Okay. Then we have right, that CA is congruent to AC. Okay, and this is by reflexive property. Okay, and then we have triangle. I'm just going to write out the word because it's easier. Triangle ABC is congruent to triangle, right, ADC. And this is by angle, side congruence theorem. Okay, and then of course we have BC is congruent to DC by corresponding parts of congruent triangles are congruent. And that is your whole proof for number 16. Number 17, this is the last one on here. We have parallelogram ABCD, right? And it's drawn with diagonal AC. We want to prove ABC is congruent to CDA. Okay, we know it's a parallelogram, so we know that, right, the sides are parallel, and we also know that they are congruent. Okay, and we also, right, we can use side, actually, right? This is not the only one we could use. What else could we use? We could use angle side, okay, because we know that they're congruent. Not angle side. We could use, we could use angle side angle, okay, or we could even use side angle side. Okay, angle side. Well, you can, because you know that this is congruent to opposite angles are congruent, and then you can use alternate interior angles. So really, it's kind of up to you on how you want to do this. All right, so I'm going to okay, so we have statements. And we have reasons. Okay. And so, just going to bring that down. And put it here for given. Okay, so because that's given, we can say BC is congruent to AD, and we can also say AB is congruent to CD. Or DC, okay? And that's because opposite sides of a parallelogram are congruent. Okay, then we can say AC, right, is congruent AC is congruent to CA by reflexive property. Okay, and then we also have then triangle ABC is congruent to triangle CDA, and we used for this one side, 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 triangle congruence theorem. Now, you do not have to use side, side, side for this. You can use other theorems. You just have to be able to prove what you're doing. Okay, so I hope that this review is helpful.